So good morning everyone and welcome back to the subject electromagnetic fields, and today we are going to discuss about the topic types of charges. So here we are going to start our topic. So let's start our topic, types of charges. So in the last session we heard about the charges. A charge is nothing but a positive charge or a negative charge which are having an electrons in an electric charge. Coming to the magnetic fields, these charges will flowing in a conductor, and that flow of conductor is called as current. These are the two types we know. But now in this electric charge, the charge where we have been considering the Q, we all know that the charge is a positive charge and negative charge. But here, coming to the combination of these charges, this has been classified into four types. Let's see the types. One is the point charge, and second one is the surface, and the third one is the line, and fourth one is the volume. This is the classification of these types of charges. Now let's remind once again, what is the first one? Point, surface, line, and volume. These are the names. Now let's see the diagrammatical representation of these charges. The first concept is nothing but the point charge. We already know that a point charge is always a single charge. A single charge is called as a point charge. That can be either a positive or negative. Now what is meant by surface charge, line charge, and volume charge? Let's make it a simple thing for you. We all know that if a number of students are standing in a line, that is called as a formation of line. Similarly, these individual charges are located in a space. If they formed in a line, that concept is called as a line type of distribution. Just the concept has given that these distribution of charges will give a shape, and that shapes are named as point, surface, line, and volume. Now let's see the surface type of distribution. Before that, let's make it simply use that line. So now we have discussed what is the concept of the line. If these charges are formed in a line, so consider there are some charges which are formed in a line, and this total value is of a charge Q. So what is the point? That this is the total charge in which the charges are formed in a line. This type of distribution is called as line type of distribution. In this line type of distribution, charges will form in a line, and that line can also be a straight line, or we can also have a curved line having charges. What is my concept is, if the charges are formed in a line, the total value of Q can be determined as this Q is equal to rho L into L. What is rho L? Line charge density. What is rho L? The rho L is called as line charge density. Means the group of charges per meter is called as line charge density. The units of the rho L will be coulombs per meter, whereas the length, we already know that the units of the length is meters. When these and these cancel, finally you are getting the coulombs. That is the total charge value in the distribution of line. Similarly, for the curved line also, we can calculate the total charge like that. The concept of calculating the total charge is nothing but, previous session we have seen the individual charge calculation of force and electric field. Now, we are not having a single charge. We are having a group of charges distributed on the space. These groups will be combinedly calculated into a single charge value, that is total charge. So this is the concept of total charge calculation for the types of charges. The first type we have considered for line. In that, you have to consider the rho L and L, where rho L is the line charge density. Calculate number of coulombs per meter. Here, if this line is of 2 meters, I am taking as 1 meter, I am having 3 charges. So here my rho L will be 3 coulombs per meter. So 3 coulombs per meter into what is my total length? 2 meters. Finally, I am getting 6 coulombs. Is it right, my dear students? So this is the way of calculation of total charge in the distribution of line. And the line can also be a straight line, curved line. Okay, always we can use the concept for as straight lines and curved lines. And we are having one more concept called as circular ring. This is also a line. How we can define it is a line? If an open-ended line is an open-ended line, if the two ends are joined together, it can be considered in the form of a line shape. So this is of circle, and this is of curved line, and this is of straight line. These are the three types in the line. The first concept is a line charge will having a charge formed in a line shape that can be either in a straight line or a curved line. Can also be a concept of circle. Now what is the logic here is, here to calculate the total charge rho L into L, you have calculated the length for straight line and curved line. Now what is the concept of calculation of a length of a circle? How can we calculate the length of a circle? The length of a circle can be calculated, the formula 2 pi r. That is the length of a circle. By using this, could you calculate the total charge now? Q is equal to rho L into L, where the rho L of a line into 2 pi r. This is the way of calculation the total charge in the concept of circle. Understood? Now let's see the next type of distribution. Let's go for the surface. Surface type of distribution. Similar concept. When the charges are formed in 1 by 1 shape, it is called as line. A surface means which is having length and breadth. So take a shape. So this is the row. Let's see the column. So distribution of charges on a surface of any shape which is having length and breadth. This is having length and breadth. Concept is called surface type of distribution of charges. If the charges are distributed over a plane in terms of length and breadth, it is called as surface type of distribution. In the concept of length and breadth, I can calculate the concept of length and breadth. We can calculate length into breadth is called as area. So in our subject, the area is represented as surface. So now what we understood that we have been calculating the area and we have been calculating the surface. Mathematical of area is technically represented as surface. Got it? Now, similar way of, I want to calculate the total charge. Total charge located on the surface. Similar concept. Q is equal to rho L into L, that is for line type of distribution. Now students, what can we do for surface Q is the total value. Instead of rho L, the L represents for line. Now what is the charge I am taking? Surface. Now I am replacing with S into L is the length of the line. Now for the surface, what we have calculated? Area, and that is represented as S. So this is for the surface type of distribution. So in this surface type, the rho's units will be coulombs per meter square, and the surface units will be meter square, and finally I am getting the coulombs. Is a calculation of surface type of distribution and calculation of total charge in the point of distribution of different charges. I am calculating the total charge for a given type of distribution, that is of surface. Just we have seen the line, and now we have seen for surface. The next concept is of volume. Volume type of distribution. Simple example, line itself indicates a single distribution. Surface is a combination of length and breadth. Now what is the concept of volume? Volume will have length, breadth and height. So what is the length? What is the breadth? And we are having height. If these charges are distributed such that we are having length, breadth and height, those type of distribution is called as volume type of charge distribution. For this volume type of charge distribution, I have to calculate the total charge Q. Just remember the previous one, rho L into L is for the line type, rho S into S for surface type. Now what would be the concept for volume? I will represent it is QV, it is QS and QL, rho V into volume, where the units of this volume will be coulombs per meter cube and the volume units will be meter cube. So finally I am getting the charge. This is the process of calculating the total charge for the distributions of line, surface and volume. So let's have an example. I am considering a scale of 5 meters which are having a charges on it, and these charges having the line charge density, that is rho L. What is the meaning of rho L? Line charge density is having 6 coulombs per meter. Means the concept is the length of the line is 5 meters. For every meter there are 6 coulombs. Now what is the concept of calculating the total charge, my dear students? Therefore Q is equal to rho L into L. The value of rho L is 6 coulombs per meter and the total length given is 5 meters. Now I got the concept that it is 30 coulombs. So what is the charge I am taken? The charge is of line type and the total charge concept is of 30 coulombs. And now if we are taken the similar example for a surface, surface will have length and breadth. So I am taking a length and taking the breadth. So for this, what I am having the charges, this is the distribution of charges of a surface. So every length will have the meters of, I am considering it is a 6 meters of length and 5 meters of breadth. In this type of situation, how to calculate the total charge? So total charge is equal to So as it is a surface type of distribution, I am considering the formula rho s into s, where the rho s value, so it's remained constant, that I am taking the rho s is 10 coulombs per meter square. For every 1 meter square, we are having 10 coulombs, that is 10 charges. So it is a concept 10 coulombs per meter square into, so area is the concept for the plane, length into breadth. So 6 into 5, so 10 coulombs per meter square, and it is 6 meters and 5 meters, 30 meters square, which is having 300 coulombs. So I think you have been cleared with the types of charges and calculation of total charge when the charges are given in the shape of line, surface and volume. And for a point charge, it is simple that the given value of a point charge is the equal total charge. I think you all have understood. Thank you.